In this video, we're going to continue topic 8.1. We're going to look at these tables that have the natural base of e and transformations. I think transformations should have been a little higher up in the notes, but we're going to summarize what we did earlier in the notes and refresh our memories on it. So if you add the exponent, if you add in the exponent, so say you have something like y equals 2 to the x plus 1, your graph shifts to the left. Remember, we go opposite when it's up with the x n units. If you subtract in the exponent y equals 2 to the x minus 1, your graph shifts to the right n units. If you add not in the exponent, as in you have something like y equals 2 to the x plus 1, your graph shifts up. It's going to be a y movement. If you subtract not in the exponent, so y equals 2 to the x minus 1, your graph shifts down, again a y movement. If you put a negative in front of the equation, y equals negative 2 to the x, then you reflect across the x-axis. If you put a negative in front of the x in the exponent, so y equals 2 to the negative x, you reflect across the y-axis. Now let's take a look at the natural base. So we've been working with a numerical base. This one is what we call the natural base e. E is just a number. It's kind of like pi in that it keeps going on and on and on and on without much repetition. It's 2.718 and so on. And be sure that you understand that e to the x is, that e is a number, so it represents a number, and x is the exponent. Approximating e can be approximated by 2.718, 281828 dot dot dot. So let's take a look at some examples with the e in them. So we're going to use our calculator to evaluate the function at the indicated value of x, and we're going to round 3 decimal places to the nearest thousandth. So I'm going to plug in the 2. So I want f of 2 equals e to the second. So I'm actually going to put that in my calculator. So I'm going to go f of, oops. So if I type it in the way it looks, f of x equals e to the x. And remember, I can hold the shift key down in the 6, and that gets me the exponent. If not, I can use in Desmos. I could use this A to the B button, also gets you an exponent. All right, now to substitute into that, I'm just going to say f of 2. And the nice thing about that is if I had more than one thing I had to plug in, I could keep plugging it in by setting it up like that. So f of 2 equals 7.3890, so it's just going to be 89. So 7.389. Now we're going to plug in f of negative 0.4, which would be e to the negative 0.4, which, hey, what do you know? We already have that in our calculator. So instead of saying f of 2, I could just erase and say negative 0.4, and I get 0.670 because the 3 wouldn't round. So negative, no, not negative, 0.67. 0.670. This one's a little bit different. I'm going to find f of 0.01. So I get 20e to the negative 2 times 0.01. So I'm going to have to change what I typed into this part. So it's 20e to the negative 2. I'm just going to edit that. And then I want to find my value at f of 0.01. So it looks like it's 19.60, and because it's a 9 there, we would round it to 4. So 19.604.